Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show we're going to be taking a look at actually building out a desktop environment for Alpine Linux on Raspberry Pi. We're also going to include some RDC access, which is remote desktop connection, which is going to definitely make life a lot easier if you want to access it remotely using a Windows machine. So let's get into it. We're about to get extended. So what I have here is actually a Raspberry Pi 400. It's just going to make my life a little bit easier, but really internally it's just a Raspberry Pi 4. This doesn't work on Raspberry Pi 3, 2, or 1, just because it's not going to have enough RAM to be able to support it on Alpine Linux. Remember, because of the way that we're using this, it's all going to be running from RAM, not from disk. So it's about a gig of actual files that have to be running before you actually add any user space files in order for it to be able to effectively even start. So it's a lot of space, and the additional RAM that's provided for it by either the 400 or the Raspberry Pi 4 is enough to be able to get it running. So in this case, just for simplicity, I'm using the 400 just because it has the integrated keyboard, so I don't have to have a separate device. But it works just the same on the Raspberry Pi 4, and all of the commands and everything else like that we're going to use are ubiquitous and interoperable between the two. So here I've already booted into the environment. What I did is I took a copy of the... Oh, I just noticed my camera's off. So pretty much what I did is I took the AArch64 image, which is the one that you need in order to be able to actually run on the 400 or the Raspberry Pi 4 effectively. And also it will give us a bit of a performance boost in terms of the user space as well, just making sure that it's not going to be splitting up computations that require that bit depth. So as far as what's there, I did pretty much copying over the files the same way that we did in the installation video for Alpine Linux initially. And what we're going to do differently this time, because this is just a vanilla installation, is we're going to set it up with a few customizations that I think are going to make it a little bit easier to go through. So we're going to be repeating a little bit of that stuff, but as far as copying over the files to the drive and then putting it into boot on a FAT32 format, that's pretty much all that's been done so far. So I've already booted it up, and we're just going to log in with the default login, which is root. And that takes us into the OS. And pretty much we're just going to be covering the prerequisites here. So first we're going to run setup Alpine, just like we would normally. Right, it's going to ask for a keyboard. So I'll do US again, just for me. For the system host name, I'm just going to call it desktop demo. I'm going to set up Ethernet because obviously we have to download some packages in order to make this work. So I'm going to do Ethernet 0 DHCP and then done. For any additional network or manual network configuration, I'm going to choose no, which is the default. And it has an IP address, just it's, in this case, it ends 137. You know, it doesn't really matter. Yours is obviously going to vary. But it's asking for a password. So I'm going to enter a very, very secure password. And then it's going to ask for the time zone. In my case, it's going to be US Eastern. Any proxy server, in my case, no. Time server, we're going to use Crony as the client. And I know there's actually a thing I ran into with my network where I block a lot of the external NTP requests just to keep overall traffic down. So if it's not able to get the time, it may present an error when we actually go through it. And in this case, it did. So the SSL certificate is invalid because it's showing the wrong date. So I'm going to just go back in after this and we'll set up those individually. If you ever run into this type of issue where the clock isn't syncing, that's the reason why the SSL comes up, but you can actually complete the rest of the setup perfectly fine. So we'll just we'll type done for now. And do we want to set up a user? In this case, we do. And we're just going to call it my user. And we're going to give it a full name. and we're going to give it a password. Again, very secure. We're not going to give it an SSH key at this point. And right now it's asking, do we want to set up an SSH server? We do. We're not actually going to use it today, but I am going to set it up just in a way that allows us to be able to access it remotely should anything go wrong. And so it says no disks available, but we're going to be running it in diskless mode using LBU to be able to save configurations. And I think that's part of the advantage of this particular setup versus using something like a Raspbian or excuse me, Raspberry OS, things like that, at least out of the box, is that we have the option to be able to make it so it will discard all changes to the OS on every reboot. And that could be useful for things like learning environments where you don't necessarily know what changes that they're going to be making, but you do know that you want to make sure that the changes are abandoned at the end of every session. So all you'd have to do is reboot the machine instead of re-imaging it. So that's definitely an advantage of doing something like this. Although I will say Raspberry OS has added the ability to be able to do pretty much run from RAM mode, which you could set up through Raspberry config. But at the end of the day, we're just going to cover this. We'll cover that in future videos when we cover the Raspberry Pi OS, just as far as how to be able to utilize that similarly. But this is much lighter weight and is certainly something that is good for kiosks and things of that nature as well. So we're not going to install to a disk. We're just going to go with the default option. Again, we're going to store configs to the default location, which is the memory card. And we're going to make the APK cache on the memory card as well. And now we've completed the setup Alpine. So now let's fix our date really quick. So I'm just going to run in. I'm going to do vi, go to etc, crony, and then crony conf. And I just need to change these two particular values, so bear with me. All right, we save that out. And restart crony. And pretty much what this will do is it will bring our date up to the current date, and I'll check it after it finishes running. And it is showing the current time, which is 1:08 a.m. So this is a live stream. So now we'll be able to run and set up the actual repos because the SSL certificate will be valid. So we're going to do just that one section. So we'll set up APK repos. And it's pretty much going to display the list that I was trying to display. In this case, it wants to show us more. We're just going to hit Q to go to the option where it's prompting us. And we're going to choose option 1, which is the default. So now we've set that up. I want to change one other option as well, just because in this case, since I'm just accessing it locally, I want to be able to just log into remote directly, which will make things like FTPing and things of that nature useful for the future, but for a production system, you wouldn't necessarily want to do this either. So etc ssh sshd config, and just go down here, and this is usually what it prompts if you don't create a user, which is what we showed inside of the when we did the other demo for the tutorial on how to actually install it. We just set this to yes in that location, but I'm just going to set it to yes here, which will allow me to use a password to be able to log in. If I did prohibit a password, I would have to use a key, and if I set it to no or just left it commented out, it wouldn't let you log in as root at all, which is best practice for highest security since root is a known username. And I apologize if I sound a little crackly here and whatnot. I've been a little bit under the weather this week, so, you know, bear with me. So now that we made all those changes, we want to save the configuration by doing lbu commit-d. So now all of those settings are saved, and pretty much we're done with all of our prerequisites. One thing I do want to mention is a lot of the packages, well, I say that we're done, but one of the things that we do need to actually set up is enabling the community repository. So we're going to do vi/etc/apk repositories. This second line right here, we just want to delete that hashtag at the beginning, which comments out that particular community line. And that will let us make sure that we can access everything. And then we can do LBU. So I'll do apk update, and we know it works because we have 19,000 packages available instead of like 9,000. So big difference. Moving on from there, now we're actually going to get into kind of how we're going to install the graphics interface itself. So what we actually have to do, and this is a very important step because this actually took me probably an hour or two to actually figure out what the right command was in order to be able to get it to work, because it kept, despite running it, it wouldn't run. It kept saying that it couldn't find the screen. So the reason for that is that because on Raspberry Pi, things like that, it's not actually registered as a PCI device. It's integrated into the CPU itself. And that means that it's not going to necessarily show up the same way. So we have to put an overlay, or a DT overlay as it's called, in the actual configuration file for it to boot and load that particular module by default. So the way that we're going to do that is we're going to mount the disk that's currently in read-only, the SD card. We're going to mount it as read-write, just temporarily. And it will clear out the next reboot. But we want to make sure that we can access it now. And we're going to do a little o, so -o, and then we're going to do capital RW, lowercase rw, comma, and then remount. And since it's already mounted, that will let it know that we're remounting it from RO to RW. That's pretty much what we're doing. And it doesn't prompt anything, it doesn't error, it doesn't do much of anything. But the nice thing is now it's directly editable. So we can go in, we can do vi media mmcblk 0p1 userconfig.txt, and it's likely it will not exist by default. So config.txt will exist by default, but on the Alpine Linux image, it actually has a bunch of stuff and then references the userconfig.txt for your own customization, because it could get overwritten if you do, like, for example, upgrades and things of that nature. So just set it to usercfg.txt, and that will keep it, that will put it in the place where the developers initially intended it for that type of thing to go. So we hit into here, and I've already pre-populated this just because it makes it easier so we don't have to reboot it now. But we would add a DT overlay, and then equals, and then the command is vc4-fkms-v3d. And then because we're running on a Raspberry Pi 4, or in this case a Raspberry Pi 400, we want to add arm_boost equals 1, which is actually related to a power optimization, where there's a separate regulator to be able to provide more power to the CPU to facilitate things like overclocking and making sure that it's not short on power where it would have to throttle. So boost equals 1 is the default in the Raspberry OS, but we need to set it here manually just because it's not the default in Alpine Linux, since you can use this on any other version as well. And then we want to disable overscan in this case. And what overscan is it's a black border that will appear around the screen. So if you're using computer screens, things like that, you don't actually need the overscan because it's going to show all of the pixels. But if you show it on a TV, for example, you may have to enable overscan in order for it to show the entire image. But it makes your overall real estate of the screen a little bit less. So in our case, we want to disable it just because we're going to see all of the pixels. So it'll just make our lives a little bit easier. And those are the 3 that I would recommend. You can also set things like your actual resolution here, but we don't have a need to do that today. So we didn't make any changes. I didn't have to write it out, but if I did QW, it would have written it out. So now I usually like to do LBU commit -D anyway, even though it doesn't actually save it there. It just makes me feel good to know that before I reboot that I'm going to do that. And we'll go ahead and reboot right now. Right? So we have a vanilla OS that we just did the basic configuration on. It's just going to quickly reboot, and it's going to load back that configuration that we just saved. And it's going to include all of the parameters that we just set. So as far as actually going through loading the overlays, everything else like that, it's all going to be included. And we see it's booting up really fast. So, and it will take a little bit longer after we install all of the packages and everything else like that. But, for the purposes of what's already loaded, I would say it's still going very fast. So now we're back to the login. We can log in again as root. And just to clarify, I am doing everything through this. So through the 400 itself, just directly on the Pi. And we're going to keep it that way. Excuse me. We're going to keep it that way pretty much for the entirety of what we're doing here today. So it'll just make life a little bit easier. You don't have to have an SSH access or computer to access it through like we have been in the past. So just end to end, keep everything simple. Type in our super secure password and we log in back to the desktop. So now we're actually going to start the setup itself. So we've done all of the prerequisite work, we've loaded our drivers, we've gotten the hardware ready, and we're now in the point where we can actually load the desktop. And guess what? Since we did all of the work, pretty much there's a pre-built function to do almost everything. Almost everything. And the command is setup desktop. We hit enter. It's actually going to prompt us for the desktop environment. And setup desktop itself is included as the base installation of Alpine Linux. And it comes with a number of options that we can set up for the desktop, which is the Genome, Plasma, and XFCE. If we choose none, it just exits. But in our case, we're going to actually do the demo on XFCE just because it looks nice. It's pretty modern. Genome is a little bit older, and a lot of the distributions and everything else like that of Linux and variants, etc., have switched over to XFCE. Pretty much at this point. So I think it's pretty current, and it should be the way that we're just going to keep it simple and just go that way. So we'll type in XFCE, hit enter, and it's going to install a plethora of packages. So 308 packages. It's about a gig worth of actual stuff. And we're just going to let it run. It's going pretty quick, but it's a lot of stuff that it actually has to load in. And just keep in mind that it's going to have to reload this every time that it reboots. So it won't take a lot longer in order to reboot, but obviously it's a lot more stuff in play. So we went from about 20 megabytes worth of used space to about 835 megabytes of used space at this point. And that's the reason why it can't actually run on a Raspberry Pi 1, 2, or 3. There just isn't enough RAM because, again, Alpine Linux is going to segment off and actually put half of the RAM, for your actual runtime, and then half of it for your use as regular RAM. So it'll show up as, if we do df-h, we can see that our slash, and this is a 4 gig 400, by the way, Raspberry Pi 400. So, and I don't have a pointing device, unfortunately, but if we look about where the slash is, where it says use is 44%, it shows that out of a size of 1.9 gig, we're using 829. So we're using almost half of it. So pretty much 4 gig is probably the smallest amount of RAM size that you can go on one of the Raspberry Pi 4s to be able to run this. I don't know that the 2 gig might run it, but you're not going to have a lot of real available space to be able to do much of anything. So just something good to keep in mind, and obviously the more RAM you go, the more actual storage space that you will have. But remember, anytime you reboot, if you don't run LBU, it's going to wipe it out. So just keep that in mind. So you may need to set up additional storage, which we're not going to do today. So pretty much going on from there. So we've set up our base desktop installation, but we need to add a few other packages just to make everything work appropriately. And one of them is the ability to be able to shut down and restart. And part of that is pretty much, or the reason that it doesn't work by default is privilege escalation. So in order to do that, we're going to install two packages. So we're going to do apk add, and we're going to do e login and polkit dash e login. And we run that, it installs about 10 packages. We're up to 840 megabytes now. Not too crazy. Now, we also want to set up our UDEV environment. We're going to use a default package again, which is setup devd. And we're just going to do UDEV. It's just a best practice, optimizes everything. But again, I'm not going to go into the explanation. It's not worth it. Just run the command and it makes everything go very well. Pretty much it does run it as part of the other thing, but because we're putting in elogin D, it's good to update it after we do that installation. So next, we're going to add the ability to be able to auto mount USB drives. So when we plug in a USB drive, by default, it will not actually load it, so you won't be able to access it unless you actually manually mount it. We want it to be able to auto mount it. So we're going to add two packages to be able to do that. So we're going to do apk add gvfs and udisks, plural, so udisks 2. And we add those. It adds a whole bunch of stuff. We're up to 853 meg. Perfect. And now we can do lbu commit-d. Excellent. Now we've saved it out to disk, so the next time that we reboot, which we will be in a second, everything should start up automatically and work. And just to make sure, we're going to do rc service light dm start. And lightdm is actually the window manager that we're using as part of this. So that's pretty much going to be initiating the launch of XFCE to be able to start it. So that way we could start using it. So kind of sits underneath it if you think about it. So now that we've run that, we say it's starting the display manager, everything else like that. No errors, everything's green, it's all happy, but we still see a command prompt. So obviously we're not exactly where we want yet, but we're really close. All we have to do is reboot. So now we're rebooting the OS. I'm going to take a sip of water. We're going to see it's taking a second to actually start up, just because we'll see the same loading bar going across the screen with some additional messages as it's actually loading those individual packages. Right, and beyond that, it looks pretty normal. And we are just going to take note of the IP address. It's the same one, the 15.137 that's coming through. And we're going to use that later when we install remote desktop to be able to access it appropriately. But we see now, instead of coming to a command prompt login, we came to a graphical login. And I actually have a mouse hooked up here. So this is the official Raspberry Pi mouse. I just got this as all as a kit, pretty much. And it all came together with the power supply, everything else. But it's an official Raspberry Pi mouse. So it actually feels nice in the hand. I'm happy with that. But we can see as I move it around, I'm able to use it as a regular mouse. So we have like a full graphical desktop here. But by default, when we click here, instead of coming up as root, it came up as my user, which is the user that we created in setup Alpine. And that's best practice. You don't want to log in as root necessarily. You can escalate to root later as a second challenge password, but it's better to just log in as a regular user credential. So we'll type in our super secure password, hit enter, and we'll log in. And just so you know, this is only running a 1280 by 720 resolution. So it's, you know, it'll run a lot bigger, and we'll actually run it in 1080 when we access it through remote desktop. But for the purposes of this, I didn't override it to make it bigger just because it makes it harder to read. And especially in this particular application, if you actually look at this, I just have this outputting directly to the capture card. So my monitor is actually the the screen, the OBS that's actually doing the stream itself. So makes it a little hard to use it because it's a bit delayed, but it's not too bad for this application. I just wouldn't want to do it every day. So, but we have a full desktop environment here, right? So we can right click, we see things are there, we can go to settings, we can create documents, things like that. We can access a web browser, assuming I clicked it. There it is. And it's going to come up with the first start page, which we don't really care about. So we're just going to open a new tab, and we're going to close this out. And let's go to youtube.com/@extendedgreg. Wow. Amazing. It says I have 49 videos. It's soon to be 50. So, yeah, and we see what we're doing right now. We have the live stream going, everything. So, pretty much, you know, it's working as expected. The only thing that's not handled in this particular installation is we don't have audio, which we'll cover in a future video, assuming I can get it working. So, you know, it's something, there's a few caveats, things like that, where it's not necessarily optimal, but if that's the case where you're trying to go for that type of thing, it may be something where you need to use an external audio card, which will show up by default, or come up with, or use a different OS if that's really your intent. And, you know, Raspberry OS obviously will work with audio by default, but because this is a bit more tuned for doing more embedded applications, things like that, you know, there's some compromises here that make it so you're doing a few more things manually. So we can close out of that, and we can take a look at a few other things, but we have this is our SD card right here. Our file system is our regular root. So we can access everything just like we would normally on a Linux OS. But the big thing I want to point out here, and I'm just going to demonstrate this and then we're going to reboot again and log in, is I'm going to create an empty file. Right? I'm calling it test file. Okay? And now we can reboot. Now, I do want to point this out. There's no reboot option here, and if you actually go to shutdown, it will prompt, but it says, are you sure you want to shut down? I don't want to shut down because, you know, there's no power button or anything else like that that I can click on the Pi 400 to be able to make it start back up. I'd have to unplug it and plug it back in. So I'm going to go and just do a quick reboot here. And the way I'm going to do that is because we didn't install sudo or anything else like that. We do su root. Prompts us for the password for root. So I'm going to type in the super secure password for root. And now we're at the root login. And now I can just do reboot as normal. And we'll be using this again in a second in order to be able to install the remote desktop packages for remote access. So we see it's restarting right now. And just so you know, those bars that come up are just the capture card indicating no input. So that's not actually generated by the Pi. The little color swatch that comes up after that, that's the square, that is generated by the Pi as normal. But just so you know what you're seeing. And just while we're waiting here, if you do like this video or like to see these types of videos, be sure to hit that like button. And, if you want to leave a comment or share it with a friend, I definitely appreciate that. And I will respond to all the comments that I do see come up until it gets overwhelming and I can't do it anymore. But to this point, hasn't been an issue. So we'll log in again. Right, so we logged in as the same user. And we see the file is gone. Magic. So it's a great way to make sure that we're not accidentally fouling our system by doing experimentation, things like that. You just got to make sure that you save your work to non-volatile storage like a USB drive or something else like that. And we did go over how to save like home directories and things like that to external drives previously, and that will still translate over here as well, just because it does follow the actual settings for that user in the OS. So something good to know. So let's continue with our setup. And this is obviously optional. You can just leave it here. Everybody will be happy if you want to use it locally. But if we want to be able to use it remotely and be able to access it as, to be able to do remote administration and then run the Raspberry Pi headless, this is a good way to do that. And I like remote desktop over VNC, VNC just to be able to make it easier. It's already installed on all Windows OSs by default, or at least the professional versions or better, professional enterprise. So it's something good to be able to use. So we're going to open it up again. It has the $sign indicating that we're a standard user. We want to obviously get to the hashtag, which indicates that we're logged in as root. So we're going to do su root again. And we're going to type in our super secure password. And now we're at now we're logged in as root with the hashtag. I type cd with no argument to get back to the home directory. Doesn't really matter, but just cleans up the interface. And I am going to make it full screen just so we could see it a bit better. So this is technically a terminal emulator. Doesn't really matter. You can access it either by the bottom bar, or you can actually access it through the applications menu up here, terminal emulator. So just so you know. So now we're actually going to install two packages. So we're going to do apk add xrdp and xorg xrdp. We hit enter. It's going to install a couple of packages. It's going to generate our RSA keys because obviously remote desktop is encrypted. We're up to 860 megabytes total. And next we're going to actually register them to start. We're going to start them and then register them to start on boot. So we're going to do rc service. We could also do /etc/init, but in my notes I put rc service, so we're going to do that. So rc service xrdp start, and then xrdp dash sysman, which is session manager, start. Okay, so we started those two packages. Now we're going to add them so they start on boot. So we're going to do rc update add xrdp, and same thing for sysman, for the session manager, and added it to run level default. Now we're going to do lbu commit -d. Perfect. And now we're going to reboot. Perfect. And those are the bars I was talking about. So we're going to give it a second here. It's going to come up. And then what we're going to do is we're actually going to access it through remote desktop. So let me prep that while we're waiting here. So we're going to let it boot up fully. We're going to show our patience. And you see how it actually takes quite a bit longer because we have so many packages that we actually have to install. because it is doing an installation with whatever the changes were that were made to it, overlaid over the top. So that's kind of what that's kind of why it takes so long. But I think it's still pretty quick overall. It's a lot faster than it used to be. So now we're back to our login. So I'm actually going to launch remote desktop over here on my Windows machine. Just going to initiate the connection just to make life a little bit easier, and we're going to switch to it. There it is. So right now it's prompting us for how we want to log into it. So we can do xorg, we can do xvnc, vncny. In this case, we're just going to leave it as xorg because that's the option that we chose to install, the xorg xrdp. So we're going to do xorg. Our username is going to be my user. And the super secure password is going to be input. And this is a 1080 screen, by the way, so everything's going to show up a lot smaller because remote desktop conforms to whatever resolution you set. So if we actually switch back to the computer, we see it's still at the login prompt. So we don't actually have transparency to the local user. If we were using VNC, if somebody had a monitor plugged in, they could see what we're doing at any given time. So that's part of the reason why I like remote desktop over VNC, is it technically is a virtualized desktop that runs in the background. So, and let me use the correct mouse. We see we have all the same options. We can open up our SD card. Whoop, there it is. I may have opened two. But we can snoop in here. Look at our file system. We can look at what's in our user. Everything else like that. And technically, there's some additional packages that we need in order to be able to browse the network and access network shares, which is specifically the SMB thing as well. But again, we're going to go over that in a separate video. I think it's a little too much for today. So we're just covering the basics, but I'll just give you a quick tour. Down here, we have our files. We have our terminal. We have the ability to be able to minimize all of our windows and show the desktop like we see here. We have 4 different desktops that we can choose. So as an example, if I was to open up a terminal window here, I can click here and have a fresh desktop to be able to work on. That's called desktop switching, and it's just, or workspace switching, excuse me. And it's very useful. So it just is like having multiple monitors that you can switch between very quickly, and there's even key commands to be able to expedite and make that a lot easier to be able to use. Here we have our browser. In this case, it showed up as Firefox, but obviously you can install other browsers if you want. The icon that's shown here is just the default for web browsers, generally for the operating system. And then Application Finder if we did want to find something, and then our home folder. So if we had our home folder, for example, mapped to a separate drive, we could actually access that here. And we also have the option to select this menu up here. We can run programs, pretty much do everything. It has a mail reader. We're not going into that ever. And then we can go into settings, and it actually has a lot of settings available that we can access. We're not going to go into those either. But something that's nice is display, things like that. We could change our resolution, and it just kind of works. And it's actually very nice to be able to do it. So you can add multiple monitors, things like that otherwise you'd have to go through a number of commands to be able to apply here just on the fly through a GUI if you're used to that. And then I shouldn't have exited out, but that's all right. Yeah, we can do Power Manager, mouse, everything else like that. It's wonderful. Everything is just like a regular operating system. So pretty much we go through their system. We don't have anything installed, but we could install whatever files and applications that we wanted to be able to make it do the kinds of functions that we wanted. And even with desktop settings, we can change our wallpaper to be something creative, whatever the defaults are, or load in our own. Choose our menu options, choose our icons, etc. And it all just works. So it's very useful and it's very easy. And the nice thing is, if we were to open up, and this is specific, I mean, this works both for VNC as well as remote desktop, but if I was to close out of this session, for example, and I don't know that you're going to see it here is the issue. So I'm going to close out of it. Okay, it did fully close. And then I re-enter it. All right, so we log back in under the same user. We see that it picks up exactly where we left off. So as long as you don't shut down the machine, everything is preserved. So it's a great terminal services server running on a Raspberry Pi. So it's a good way to be able to access a discrete Linux operating system that's not just running under the Windows subsystem for Linux or WSL 2 driver, which again is a good way to access Linux, but you have limitations in terms of what you can do as far as formatting and disk access, things of that nature, that makes some operations kind of difficult. So being able to do it through a physical machine is, that's running it natively, can in a lot of ways can make things a lot easier, or at least more consistent. So that is pretty much what I have. So thanks for watching the video today. If you like, or the stream, which is now a VOD. So if you like it, please hit the like button and leave a comment down below. And if you think somebody you know will like this video, be sure to share it. Sharing helps out a lot in terms of the YouTube algorithm, and I will definitely appreciate it. And if you haven't subscribed, please subscribe. And make sure you hit that notification bell. That way you know the next time we're getting extended. So until then, take care.